Hello everybody. This is a quick tutorial on how to use Git and GitHub for Windows. The same commands work for Mac operating systems, but your mileage may vary due to how the terminal looks and how Safari operates. But that should be easy to figure out. So let's get started. To use this, we're going to have Git installed in our computers. And to do this, you can go to git/scm.com/downloads. And from here, you can download Git based on the operating system that you have installed in your computer. I'm going to be using the Windows version today. So once we have Git, we need files to work with. And so as a sample, we're going to use the EBA Diaries Volume 6, which is an XML document that is the Emma B. Andrews diary that has been digitized. So to use GitHub, you're going to have to create a GitHub account. I'm going to assume that you already have one created and that you have access to the EBA diaries. If not, you can get that sorted out and come back to this video. Once you have an account on GitHub, you'll see the master repository right here. So what GitHub does is it keeps track of a collection of files, and that group of files is called a repository. Now what you're looking at here is the repository page for EBA XML Volume 6. Right here you can see the files included, and you can see that we're working on the master branch. A little bit more on that in a couple of minutes. So to use your own version of these files, you're going to want to fork it. Up right here in the right hand corner, you can click fork, and you can fork the repository to your own account. I've already done this, and so it won't let me do it again, but it'll take me to it right here. And once you fork the repository to your own account, you will see a new page that looks very similar, only over here it'll have your username, in my case Brad Holland 84, and it'll tell you that you forked it from the EBA diary version of XML Volume 6. These are the same exact copies of files as you just saw in the master copy, except once you fork it, you create your own version. And I'm going to have a visual diagram in a minute to show you what that looks like. So right here is a diagram of what we just did. So the master copy, which is right here, is EBA diary / EBA XML Volume 6, and once you fork it, you create your own version. In my case, Brad Holland 84, EBA Volume 6. So how this works is that GitHub keeps track of files in sequential order of when they were changed. So the master copy here will have multiple versions. So once it gets updated, it'll have version 1.1, version 1.2, and so on. And the tree will kind of go down like this. When you fork it, you kind of copy the files and you take it over to another branch in the same tree, which is completely separate from the files over at the master. Now what this means is that any changes that you make and commit to your own repository, the forked one, will not reflect on the master copy, which is EBA diary, which means you can do whatever you want to these files and the originals will not be changed, which is nice because it allows us more flexibility and a little bit of security in regards to changing a bunch of files. So let's get started with using Git. So once you have the GitHub repository forked to your own GitHub account, you're going to have to take this URL, which is called an HTTPS clone URL. So what we're going to do first is clone the repository down to our machines, because right now the files are just sitting up in GitHub, which is a cloud service. This is what it looks like visually of what we're about to do. So GitHub is a cloud service, which means that the files up on GitHub are not locally accessible on our computers. So if we draw a simple computer down here, right now the files are all up on GitHub. If you think of these files, the three being some of the XML files, the documents that are kind of sitting up in the cloud. I apologize for the terrible drawings, but work with me here. So what we're going to do is pull these files down from the cloud to our local machine, which is the computer that you're working on right now. And to do that, we're going to use a command called git clone. Now, clone is kind of like copy. Basically, the clone command will take a copy of the files from GitHub and pull them down to your machine in the exact way that they were before. So let's do this via the terminal window. Alright, so I pulled up a git bash window. To do this, you have to type in start, type in git bash, and you should see the program pop up. And once you open up a bash window, or a terminal window if you're on Mac, you'll see this screen. So what this does is it's a command line that allows you to tell Git to do certain commands. So right now, we can do some different commands using the command line to pull down the files from our GitHub account. So right now, I am in my main user folder. So if I can quickly change over to my desktop by doing cd desktop, right now the Git window is pointing at my desktop, which means anything that I do here or create will show up on my computer's desktop, which is easier to work with. So what I'm going to do is type git clone and then paste the URL that I got earlier from this page. So git clone, I can do edit, paste, and press enter. And what this does, after a few seconds, will tell you that you successfully cloned the copies of the files down from GitHub. So basically, we took the files from the GitHub cloud and we cloned them down to a local machine in the exact way that they were up in the cloud. So if we go to our desktop, we can see that the file folder is right here, and if we open that up, we will see that the files are located in a folder in the exact same way that they were up on a repository up on GitHub. Now, as you can see, there's a third folder in here that's hidden to most users called .git. And what this does is it's a simple way for Git to keep track of the files that are located in this folder, because right now Git is basically watching this folder, and so any file that is changed inside of this folder, Git will be able to say, yes, okay, you changed that file. Then once it knows that, that means you can save those changes and push them back up to your GitHub account. So the .git is just a nice little indicator that yes, Git is watching this folder of files, so this repository on my machine. So if we go back to our bash window, we can do a couple of commands with this window. So if you type in git and press enter, you'll see a list of every command that is available to you. There's a short description about what they are, but we don't have to use all of them, just a couple of them. So obviously, with the files that you clone to your local machine, they're now located on your machine like any other file that you would have on your computer. So you can make changes pretty much as you wish. So let's take the volume XML document and make a couple of changes, because this is what you're going to be doing with your diaries. So right here is the diary, the text XML of the diary, and I can make a simple change. So if I go to body, maybe I can type my name in here. Pretty easy. And if I save that and go back to my Git window, I can use a command called status. So if I say git status, Oops. You're going to have to run into this often. This is actually a pretty common mistake, which I just made. So right now, I'll explain what happened. Basically, right now my terminal window, or my bash window and on Windows, is pointed to my desktop, which is the whole directory. But there's a couple of things in my desktop that I have to go into first. So if I list all the things that my desktop contains, I can see that, oh, EBA XML Volume 6 is actually a folder within desktop. And so I have to use CD, as for change directory, to change into that folder. So if I do CD EBA XML Volume 006, then it will change to that directory. And what's nice is you'll know that the repository of files is a Git repository because it'll usually have the name of the branch that you're working on right here next to the folder. So right now we're working on the master branch of my fork of the repository. And if I type ls, I can see the files included, and I can see that, okay, yes, the XML document is still right there. So if I type git status, now that I'm in this repository and I can make git commands, it'll show me that one of the files was modified, which is correct. I just typed my name in here and the file, and because Git is watching this file folder, any changes to files that I make will show up in the version control. So how do I save these changes? Well, I saved the file in Notepad like this, but that didn't actually save the file in Git's mind, because Git is a safer way to keep track of files and to make sure that you make changes that you want to do. And so you have to do a couple of extra steps to make sure that the file is saved. And this is called a commit. The word commit actually makes a lot of sense because it's kind of like you're committing to the changes. So you make them and you have to commit to them, kind of like a double check. And to do that, we have to add these files to what's called a staging area. So I'll show you what that looks like. Basically, when you make a bunch of files, you'll have them on your computer, but they're not staged yet. So what this does is it takes the files and you have a kind of like a virtual stage. So right now the files are on your machine. Let's say this is the .xml file that we just worked with. And this is the stage. So to push files up to the cloud, we first have to stage the files and tell Git that, yes, I'm ready to do some commands on this. And so we have to add it to the stage virtually. So if we go back to our bash window, we can type git add period. Now the period stands for add everything, but if we wanted to, we could type in the name of the file that we want, aka volume-6, blah 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 blah, but that takes a long time, so I'm just going to add everything, which includes the one file that I modified. Now if you look here, it says changes not staged for commit. And what Git is telling you, and the reason why this file name is in red, is because the files that you changed are not yet staged, which means this virtual stage over here is empty. And the file is just kind of sitting in the audience, if you can think of it that way. So we first have to add the files to the stage. And so git add period will take the file and add it to the stage so that we can commit our changes. If you type in git status again, you can see that the file is now green in Git, which means that the file in our desktop folder right here is now added to the staging area. So a staging area is the place where files go so that Git says, okay, when I want to commit to these changes, I want to use everything that's on the staging area. You can have 1, 2, 3, 50, 100 files on the stage at once. And when you tell Git to commit those changes and save them, it'll do everything at once. Right now we're only working with one file, but you can do as many as you want. So the file is green, which means that it's ready to be committed. So the next command we're going to use is called git commit. Now before you press enter, you have to include a message. This is because Git is a teamwork sort of software. And so when you make changes that you want to save so that everyone can see them, it's good practice to actually leave a message for other people so that they know what got changed. And you can type in any comments that you have, a work log almost, but all these changes and notes can be viewed later in a history. So to append a message, we use -m, which is just an optional little parameter that would allow you to type in quotes and type your message out. So I can say, I added my name to the body, end quote. So I'm including a message with this save, with this commit, saying, okay, I changed the file right here, and I told my team, I added my name to the body. So when I press enter, it'll give me a little confirmation that, okay, one file changed, I have 2 insertions and 2 deletions. And so that's just kind of telling me, okay, what did I insert into the file, what did I delete from the file? Now if you go back to git status, we can see there's nothing to commit. So the working directory, which is the file folder in my desktop, which is right here, is now clean, which means you've already saved everything that has been changed. So there are no pending changes that as far as Git is concerned. So once your working directory is clean, we're done, right? Well, not really, because what happened is that we committed everything locally. And so right here we're kind of working within our local machine. So right now Git is watching our local machine. So it's got eyes on our files here. Now we committed those changes, which means we put them in the stage and we committed them. So we have a file and we committed it, which means it's now saved in the eyes of Git. But that's just locally. Now what we have to do to save those changes up to the cloud is push them back up to GitHub. So to do this, we have to use a command called git push. So push is a special command that bridges the gap between your local machine and the GitHub cloud service, which is up here. Now I'm going to demonstrate the differences between your local machine and the cloud. So if we go back to my file folder and we look at the XML document, for example, I can see that, all right, my name is in the body. That change is saved. Any changes that I made to this file are now visible in this text document. So on my computer, my name is here in the body. But if I go to my GitHub account and go to where all my files are stored in the cloud, if I look at the XML document, you'll see that my name is not in the body because the changes that I made on my computer are not automatically updated in the cloud. You have to manually push those files up to the cloud so the changes can be reflected up in your GitHub account. So let's do that. Pull up your git bash window again and bring it up front. So we're going to use the command called git push. And if you press enter, it's going to prompt you for your username. So in my case, Brad Holland 84, which is my GitHub username, and then it's going to ask you for your password. Now what's kind of weird about the terminal and git bash is that they actually hide your password. So while you're typing it in, it won't show you what you're typing. So just take it easy and try to get it the first time. So I'm going to type in my password and press enter. And it'll give me a confirmation saying, all right, there's 5 objects. They compress them and they push them up to my GitHub website, which is github.com/BradHolland84/EBA XML Volume 6. All right, now if we go back to GitHub and go to my repository, whoop, let me do this. You'll see that if you go back to the XML document, whoop, there it is. The changes are now in my cloud repository up in GitHub. And I can look at the commit log, which is kind of like a history of everything you've done. If you go to commits, and right here is the commit that I just made, and my note that I specified earlier is now reflected up in the cloud just like it was in my local machine. So hopefully you're starting to get a sense of this workflow that we have going on. And what's useful about GitHub is that it's very safe. And so files that you can change on your machine, for example, when I just kind of mess around in Notepad, are not immediately saved and updated in my cloud account on github.com, which is safe because I can make any changes that I want on my computer, and once I like those changes and I feel like that they're good and I want them to be saved, then I can commit to those changes and then push them up to the cloud so that everyone can see now. Because right now, this repository up in the cloud is now public. And so anyone can access these files. Anybody can clone them. Anybody can fork them and create their own versions. They can see my changes. But as I said earlier, the changes are not reflected in the master copy. So if we go to the XML document in the master copy, my name is not there because it's only on my fork, which is my copy of the files. Now, the reason that this is useful for working with teams is that whoever is the manager of the master copy, in this case, whoever owns EBA Diary, can pull changes from other forks and other users. So if EBA Diary wanted my changes from the XML document, let's say this is actually the correct translation of this document and Brad Holland is supposed to be there, they can pull the changes, and anything that I do on my end can be merged into the files of the master. All right, so let's go over that workflow one more time. Let me kind of clear this all out, and I'll show you what it looks like again. So real quick, you have to do git clone, whoops, not git colon, git clone, which copies files, and then make changes. So basically what I did earlier with editing the XML document. And then you have to add those to the stage by saying git add period, which adds everything. We're going to call this the stage file period. Git commit. Now remember to include a message. So in quotes, your message. And then git push. And then here you'll have to type in username / password. So git clone, which copies down the files. Remember, you only have to do this once. Once the file's in your computer, you can repeat these steps as many times as you need to make changes. But this step only has to be done once, because once the files are in your computer and Git is watching those files, it only has to watch it once. But once you make changes, you can add them to the stage, you can commit those changes, and you can push them up to the cloud as many times as you want, and you can do them at your leisure. So I think that's everything that you need to know right now. But before I go, let's do a couple of quick tips. Let me erase this. Okay. A couple of quick tips and errors that you might run into. So tip number 1, make sure that you are looking at the directory or file folder that Git is keeping track of. In the right folder. So in my case, that means that I'm in my PC on the desktop, and I'm in the file folder called EBA XML Volume 6. Now remember, I originally was in just the desktop, and when I try to do a command on the files, it will say there's no Git repository here. So it's looking for that file folder that's hidden usually, called Git. And because my desktop is not a repository, there are no instances of Git that are watching it. So to do Git commands, you have to be currently looking at a folder that Git is kind of watching and keeping changes and keeping track of the changes. And so to kind of go in that folder, you can type in ls, which will list all the folders or files of the current thing. So on my desktop, I have a couple of them, but there's a folder here that I know is the right repository because I just cloned it earlier. So if I change directory using cd EBA XML volume 006, now I can do Git commands because this is a repository. So keep in mind, you can't just open up a new Git bash window and start typing commands because you're not in a repository. You have to be in a repository to do commands on your files and to push those changes up to the cloud. So make sure that you're in the right folder. Also, always leave a message. What this means is after you do commit, so when you're committing your changes, remember to do -m afterwards and then your message. Now if you don't leave a message and you just type in git commit, it's going to be looking for a message. And I'll show you what that looks like. If you go to the Git bash, and we just quickly, make a change to my document just for testing purposes, and then we go back. Okay, so I'll say git status. Okay, there's a file that's modified. Git add, put it in the stage. Git commit. And let's say I forget to write a message. It says, unable to start editor, please supply a message either using M or F. So it needs a message or else it can't commit. So if I do commit M, I'll say message. Oops, it'll work. Alright. So as you can see, it requires a message or else the git commit will not take. So make sure you do that. And also, the last thing to remember is that always work on your own fork. What this means is don't try to clone down files that aren't yours. So for example, if I go to EBA diary and I look at the volume 6 and I forget to fork it into my own account, which means the files don't belong to me, I can clone it just fine because these files are public. But as soon as I try to make changes and push them back up to this account, it won't let me because you'll have to type in the username and password for an account that you don't own. And so if you forget to fork the files into your own account, you won't be able to push them back up to the cloud and see your changes publicly on your own account. and your repository will never be there, like it is in my account. So remember, always fork and then clone. And then make changes, make sure that you're in the right folder, commit, leave a message, and push them back up to the cloud. If you guys have any questions, you can shoot me an email. Otherwise, I hope this has been helpful. And as always, there is a written document with all these steps, including a bunch of core concepts and a little bit of a glossary about things like a staging area, the commit, a repository, a branch, using clone, initialize, status, add. All of these commands are detailed on the document, which can be found in the wiki, and a simple step-by-step tutorial of what we just did can be found on the bottom of the document. So you can either watch this video again, or if you prefer to read along and follow pictures, you can do that too. I think that's everything. I hope you guys have a great day, and happy committing.